So we're going to simplify here in number 4, the expression with the cube root of 64, m to the ninth, n to the 7th. And I'm experiencing a little lag between like moving my mouse and where the pen goes. So if it's a little sloppy, I apologize. But what we're going to try to do, we're going to try to break up each of the factors that are in here into factors that can be cube rooted nicely. So how about this? If something is already cube rootable, if you let that be a word, I'm going to write it in green. If something's not cube rootable, I'm going to write it in blue. So the green is prepped and ready to go. We could cube root 64. We can take the cube root of m to the ninth. We can't really take the cube root of n to the 7th yet until we break it up into n to the 6th times n. So that breakup is based on the fact that we add exponents to get n to the 7th, right? So now everything in green here can be cube rooted. And the cube root of 64 is 4. Now the m to the 9 and the n to the 6, those are perfect cubes. Not because 9 is a perfect cube or 6 is a perfect cube. It's because they're divisible by the index. Remember, if I take this m to the ninth to a breakout room up here, m to the ninth cube rooted is m to the 9/3. N to the 6th cube rooted is n to the 6/3. So that's what you're looking for. You're looking for that exponent in there to be divisible by the index. Okay? So the m comes out as m to the 3rd because it's 9/3. And the n turns out to be n to the 2nd because of 6 divided by 3. But we have to keep in mind that there still was this little n inside that didn't get cube rooted, n to the 1 or just n. So that would be a good final answer for 4A. Okay? In B, keep in mind that you're taking the square root. We don't see the 2 there, but it's understood to be there. So let's use the same technique where in green, we're going to write out things that are already perfect squares. X to the 8, I'm not going to revise this at all because the exponent 8 is divisible by 2. You're looking for those exponents to be divisible by the index. And let's go straight to changing n to the 7th to n to the, oh, sorry, y to the 7th. I looked at the wrong problem. Get rid of that. So the n to the 7th is from the old problem. Y to the 7th is going to be split up into y to the 6th. And then we'll have this extra little y. So this is pretty similar to the last one. Now you just go down the line and take the square root of 81. The square root of x to the 8 is x to the 8/2, which is 4. Square root of y to the 6th is y to the 6/2. And then you have the square root of y stuck. Now you may notice on my answer key that I have absolute value bars around this y cubed. And I'm not all that concerned about that for the test. There were even times in the book, like when I would go to check an answer, they didn't even put the absolute value bars. So don't worry about this. Okay, it's just an added layer of something to worry about that really isn't that big of a deal. So um, again, don't worry about absolute value bars when doing this. It has to do with forcing the answer to be positive because you're taking the square root, and square roots have to be positive, not negative. So, all right, so that's it. That is number 4 in its entirety.